Next up is Jessica Allen, who is also from Sustainability House, so you get 2 projects with Sustainability House today. She is a sustainable building consultant with them, and within that role, Jessica provides energy efficiency consultation and assessments for residential dwellings to ensure compliance with the National Construction Code. Jessica is also a member of our ASBN committee, so we're really pleased to have her presenting tonight. Right on, take it away, Jessica.
Thank you. I've ditched my notes, so bear with me. This is pretty scary. I'll probably forget it, and this will probably only go for 4 minutes, but that's fine. Okay, so the house I'm presenting tonight has been labelled Getting There. As you can see, it's not quite finished. The clients have moved in this week though, so it's all ready to go for Sunday, but there's still some landscaping and things to be done. But the bones of the house are there, and you can appreciate what they've done. So when these clients began this process and they decided they wanted to build their own house, they knew what they wanted. That one of the wife already worked in the industry. She knew the basic principles of good orientation, insulation, cross ventilation, thermal mass, and they did not want any heating and cooling. So they had a floor plan. They knew how they wanted the house to look, so they just needed it tweaked to suit the site. So they took their floor plan down to Bailey Homes, who's a local builder down in Victor Harbour. They're an award-winning builder. In 2009, they won the Green Smart Energy Efficiency Housing Award. So that's a really great award for them to win. This house is located in the Beyond Today development, which is located on the Fleurieu Peninsula. Almost half of the development is going to be vegetated or open parklands, and there's also going to be 64 hectares of wetlands, which will serve to purify some water before it goes out into the Southern Ocean, and it'll also provide a habitat for thousands of birds and animals in the area. This is the floor plan that they ended up with. A few things about it. The pergolas to the north will be covered in deciduous vines, so in winter they'll be completely shaded by the greenery. In summer, be completely shaded by the greenery, and in winter all the leaves will drop off and the sun will be able to enter the building beautifully. Sustainability House became part of this project from a performance optimisation point of view. We did some modelling of the house to work out exactly where the sun was going to be, at what time of the year, what time of the day. And this is a photo taken, an image modelled on the 25th of June at about 3 o'clock in the afternoon. So you can see the white sections are where the sun is penetrating into the building, into that main living space and heating up the slab. That date is relevant because I actually have a photo which proves that this happens later in the slideshow. This is a model of the summer solstice, the 21st of December, and you can see that at midday the sun is at the highest point in the sky. There is absolutely no sun entering the living spaces of this building. I'm yet to take an actual photo of that because obviously the house has only just been built, but I'm going to prove that. So once all this optimisation work was done, we ran it through our NatHERS rating software, and it came out at 8 stars. It's just a basic 3-bedroom, 2-bathroom, 1 main living area house. What I really like about this project is that there's nothing particularly space age about this project. It's just good design, the right people behind the project, the right materials in the right location, the right layout. So the house is clad in 75mm EPS, which is a polystyrene product with very high insulative properties. delivers up to 200 times its own resource cost in thermal energy savings. Lightweight, easier transport equals lower fuel costs, effective and durable thermal insulation, absolute water and vapour barrier, airtight, long life, low maintenance, and recyclable. I think there's a common misconception that polystyrene is not recyclable, but I believe that offcuts can be broken down and recreated into new panels. So the house has R5 in the ceiling, R2.5 in the external walls, and there's internal insulation as well. These timber beams, the clients were really lucky to get these. The causeway between Victor Harbour and Granite Island was refurbished in 2012, and they got their hands on some of that causeway. So they've got a beautiful piece of the local history embedded in their project. The vanity is also made out of recycled timber. This has been much more finished. But yeah, it's a recycled timber product. They've got low flow shower taps, low VOC paints, low VOC joinery, all of those things on the inside of the house. The landscaping throughout the Beyond development is all drought-resistant plants. This particular project is going to be using velveteen grass, which is highly drought-resistant, deciduous trees to the north, as I mentioned before, the deciduous vines, which will protect the house from that summer sun. So once all the predictive stuff was done, the house got built, but did it actually measure up to what we predicted? So what you do, there's various things you can do. You can measure temperature, you can also measure air tightness. So that's what we did with this fan. You stick a fan in the doorway, you turn it on, you pressurise the house, and you work out how leaky it is. This house got 3.4 air changes, which I don't know if that means anything to you guys, but basically once every 5 hours the air in the house is completely replaced. In a normal house built to sort of Australian benchmark standard, the air in the house is replaced every 1 to 1.5 hours. So you heat up your house, you're losing all of that air out of your house, out of the gaps in the windows, the gaps in the top plate, bottom plate, all those areas that aren't properly sealed during the build process. It's unintentional ventilation, and you're losing money out of those cracks in the build. So this house is very well sealed, probably too tight, but luckily these clients know how to operate their house, they know how to ventilate it, so they're not going to suffocate or anything. This is a little graph that shows, I'm running out of time, a little graph that shows the performance of a really well sealed house versus a not so well sealed house. And then the green line is the outdoor temperature. So the red line is the well-sealed house has got a higher internal temperature at the peak of winter because you're not losing all of your warmth out of the cracks. These are thermal images. The purple is where the cooler temperatures are. I'm just going to have to flick through this because I'm running out of time. Basically, the windows are awesome, double glazed, really well-sealed UPVC frames. This is the photo I was telling you about. You can see the sun gets right to the back wall, and that happens throughout the whole day. Blah, blah, blah. So solar panels, solar hot water, 20,000 litres of rainwater that services the house for the whole year. So, yay, 4 seconds to go. Thank you.